Here's an example with multiple functions to do a few function composition examples. So let's say, for example, you were just asked to find f of m evaluated at the number 7. All that would do is start on the inside most function and evaluate m at the function value of 7 first. So you'll just simply take the 7 and the m of x function, which is 4x, find m of 7, which is just 4 times 7, and that gives you 28. So that 28 is the value for m evaluated at 7. And what that has for the next step is to evaluate the number 28 into the f function. And when we do that, that is going to have us do 3 times the quantity of 28 squared, which is a big number. So if we square 28 first, let's see, you get 784. And when we multiply that times 3, you get 2,352. So that is the answer for f as a function of m evaluated at 7. Right? Another example would be if you were asked to find, how about we do r of g of x, x being the input, no number going in. So we'll take the g of x function, which is the 9x minus 2, and we'll take that entire function and plug it into the r function. So instead of r being the square root of 3x, it's now going to be the square root of 3 times 9x minus 2. If you distribute that 3, you get that that's the square root of 27x minus 6. There's nothing to really simplify there. They have a factor of 3, but it doesn't square root, so that would be your final answer for r of g of x. All right. Another example was if it asked you to find g of f of x. So that's going to take the entire function f of x and plug it into the function for g. So f of x is 3x squared. So we're going to plug 3x squared into the g function. So g is 9x minus 2. So instead of 9x minus 2, we'll do 9 times 3x squared minus 2. Distribute. Oh, I need to do 1 because there's no plus or minus. So we get 27x squared minus 2. There's nothing else to simplify. Those are not like terms. So you leave that as your answer. Another one, if you went the other way and found f of g of x. F of g of x takes the g function, the 9x minus 2, and is going to substitute it into the f function. So instead of 3x squared, we have 3 times 9x minus 2 squared. Now, sometimes you have to expand it, sometimes you can leave it in its factored form. If we work through expanding it, we would have to multiply the 9x minus 2 out twice. And I would go ahead and find the product for those. So you get 81x squared minus 36x plus 4. And then if you carry the 3 out to everything, you get that that's 243x squared minus 108x plus 12. So that's your final simplified expanded answer for f of g of x. Right? So if you start to have 3 functions, then you might have, let me erase this top one. So if it has you do something to the effect of f of m of g of x, that's a few nested functions there. So it starts by taking the g of x function and plugs it into m. So what that would look like is f of m at 9x minus 2. And if I plug 9x minus 2 into the m function, what that looks like is 4 times 9x minus 2, which is really 36x minus 8. And now I'm going to take that quantity and plug it into the f function. So that becomes 3 times 36x minus 8 quantity squared. And now we have another quantity that is squared, so we'll have to write that out twice. 36x minus 8 times 36x minus 8. This is if you're expanding it. And when you multiply that out, you get 1,296x squared. And then minus 576x plus 64. Distribute the 3 all the way through. You get that that's 3,888x squared minus 1,728x. And then plus 192. And that is your final simplified expanded answer for f of m of g of x.